3.4 quantifiers. All, any, and exist are known as quantifiers. An expression which has a quantifier applied to it is said to be quantified. They specify how many elements in a subquery must satisfy the condition. We have some exercises here. Which of the following is true? 5 is equal to any of 2, 4, 3, 5. The question is asking 5 is equal to any of this one. So we know that 5 is not equal to 2, 5 is not equal to 4, 5 is not equal to 3, but 5 is equal to 5. So the answer is true. 5 not equal to any of 2, 4, 3, 5. So we know that 5 is not equal to 2, 5 is not equal to 4, 5 is not equal to 3. So the answer is true. Again, SQL allows the use some instead of any. 5 greater than or equal to all 2, 4, 3, 5. So we know that 5 is greater than 2, 5 is greater than 4, 5 is greater than 3, and 5 is equal to 3. The answer is true. So we have another question. 5 is equal to all 2, 4, 3, 5. So we know that 5 is not equal to 2, 5 is not equal to 4, 5 is not equal to 3, but 5 is equal to 5. So only one is satisfying. It's not satisfying all. So the answer is false. 5 not equal to all 2, 4, 3, 5. So we know that first 3 is not equal to, but the last one is equal. So the answer is false. We have an example here for the all quantifier. Select word name from word where number of bits less than or equal to all select distinct number of bits from word. So we are checking the word name where the word number of bits is less than all the words, number of bits in all words. We all make sure that number of bits is less than or equal to number of bits in every word, that is the smallest of them all. Let us run this query. Select word name from word where number of bits less than or equal to all select distinct number of bits from word. So you can see you're getting an answer only Dales. So let us see what are the contents of the word table. So we can see here select star from word is displaying. Word number 2 has 8 bits. Word number W3 has 10. 4 has 8 and 5 has 6 and 7 has 14. The smallest is word number 5. Word name is Dales and number of bits is 6. So we are trying to display the smallest of everything, which is word W5 Dales. Next example, the any quantifier. Select staff number from doctor, where doctor name is equal to any select position from doctor. We are trying to check whether any of the doctor has name same as the title, his position or title. Select the doctors with the same name as any of the positions in the table. So which is not true actually. We know that no doctor satisfies the strange condition, but the query is well formed. See the equivalence between any and in. Select staff number from doctor, where doctor name is equal to any select position from doctor. So it is checking whether any of the doctor is having the same name as his position, which is equivalent to select staff number from doctor where doctor name is equal to in select position from doctor. So you can use either any or in operator for the same purpose. Next we have the exist quantifier. Checks whether or not a subquery produces any rows of query result. For example, select student ID name from student. where not exist. So which is a negation, which is where not existing. What is not existing? Select star from enrollment where student ID is equal to student ID. So here the query is finding all the students with no enrollment. Any student is there without enrollment. So we are checking, we have a subquery here, select star from enrollment where student ID is equal to student ID. So this student ID is from the student table. So we are using an alias. This alias is for the outer query table. So it will display for you any students. Is there any student with no registration or no enrollment? So while you run the query, you are able to see here there is one student S42 without enrollment. Let us see the differences between subqueries and joins. Subqueries versus joins. Many queries written using subqueries could also have been written as multi-table join queries. We have an exercise here. This exercise uses the university database. Using a join, write a query that lists the title and credit rating the courses enrolled by student S5. So we are trying to display the title and credit rating the courses enrolled by student S5. So we don't want any repetition or duplication, so we can use the keyword distinct to remove the duplicates. Select distinct title of the course and credit ratings. For credit is for the credit rating from course C and enrollment. So course will display the course title and enrollment will give you the number of courses registered or the credit registered, where C dot course code is equal to E dot course codes. We are using in the aliases C for course and E for enrollment, and we have one more filtering condition. We need to display the result of only student S5. So we use the operator AND. Student ID is equal to S05. Let us run the query without the student filtering. So it is displaying you select distinct title credit from course C enrollment E, where C dot course code is equal to E dot course code. So it is displaying title and credits of all the students. So if we apply the next filtering condition, it's only for S5. You can see S5 has registered in two courses, syntax and pragmatics. We can repeat using a subquery. The same query, what we have seen, we can repeat with a subquery. Select distinct title credit from course where course code is equal to any. Select course code from enrollment where student ID is equal to S5. So while you run the query, you are able to see the same result. So it is using a subquery. Result of subquery is compared with the any quantifier. A join is necessary when the final table includes data from both tables. Fields in tables referred to only inside a subquery are inaccessible in the select clause. Say, for example, if you try to run this query, you get an error, could not execute statement, because it is asking enrollment date. Actually, enrollment date is a column in enrollment table. So this is coming in the subquery. So this query will fail because it is not in the main query. So we did not use this table along with the from clause. So a join is necessary when the final table includes data from both tables. A subquery is necessary when a comparison is to be made with an aggregate function applied to the second table or list of values from all the rows. This is because once we put two tables or more in the from clause, a Cartesian product is automatically taken, so aggregate functions cannot be applied to the second table alone. When there is a genuine choice between a join and a subquery, there are two factors to consider. Number one, which formulation seems more naturally based on the English request. Second condition is which formulation is likely to be most efficient. So let us see subqueries in the from clause. The ability to place subqueries in from close is a powerful technique. It was not originally included in SQL, makes the use of having unnecessary, can replace correlated nested queries. So let us see one example here. You require a query to answer the following request. What are the patient identifier, gender, and weight of each of those patients whose weight is more than 10% higher than the average weight of the other patients of the same gender? To answer this query, we need to know the average weight of patients of each gender. Like for example, you need to determine the average weight of male patients, average weight of female patients. Write a query that can be expressed in English as, for each gender, list the average weight of patients of that gender according to the patient table. For each gender, list the average weight of patients of that gender according to the patient tables. You can use the query. Select average weight as average weight rename operator to change the name from patient group by gender. So you get the average weight of each gender, male and female. So we have connected to the hospital database. Let me run this query. You are able to see the average weight of patients for the male patients as well as the female patients. Let us write the query that uses the patient table and your answer to part A to answer the original request. The query that you got for part A should appear in the prompt clause of your query. Select patient ID, patient.gender, weight. From select, we are using a subquery here. From select gender, average weight. So the one what we have written before, it's written as a subquery here as P. So the result of this query is a table. So we rename this query, this table as P. Then we join the resulting table along with the patient table. Then we give the condition to this. So let me run this query. So we have seen the result of this inner query before. So it will give you 60.13 and 75.95. So the result, this is the result. This resulting table we combine, we rename as P or alias as P. Then we combine the resulting table along with the patient table. Then we gave the condition where patient.gender is equal to P.gender and weight greater than 1.1, so 10% more than the average weight. Let us run this query. You are able to see here female patients and their weight and the male patients and their weight.